When configuring object tracking with HSRP, there's really three separate configurations that you will have to accomplish. First and foremost, you will have to define the instance that you will be tracking. For example, we will be tracking an IP SLA instance in this example. And that IP SLA instance is simply a ping. We are going to be pinging this particular IP address every 5 seconds. It starts now. It's going to last forever. And then we attach that to a tracking object. So in this case, the tracking object is called 100. And we are tracking this IP SLA instance that we created before. So in this example, the tracking object is going to be up as long as the pings in the IP SLA instance are successful. If those pings fail, then the tracking object goes down. So we attach this tracking object to our HSRP configuration with the standby 10 track command. So just like interface tracking. However, instead of tracking an interface, you are tracking this object right here. So if the object is up, everything is fine. But if the object goes down, then you decrement the priority of the current group by whatever value you specify. So in this example, it would be decremented by 20. So if the current priority is 100, you decrement by 20, the new priority is 80. The goal here is to find a value that will ensure that the current active router ends up with a priority lower than the current standby router, so the standby router can take over the active forwarding role. But make sure preemption is enabled. If preemption is not enabled, especially on that standby router, it will not take over the active forwarding role. Let's set up object tracking on DSW1. So what do we want to track? Well, right now, we have interface tracking set up for gigabit 1/0/10. So if the link between DSW1 and R1 fails, no problem. The priority is going to be decremented enough so DSW2 becomes the active forwarder. But what if the link between R1 and R3 fails? Too bad. We lose connectivity. So with object tracking, we can keep an eye on the status of that link. And as a result, if it goes down, we can lower the priority of DSW1 to a value that allows DSW2 to take over the active forwarding role. So first thing we have to do is set up an IP SLA instance that we will attach to the tracking object, and that tracking object will be attached to HSRP. So first things first, let's set up an IP SLA instance, call it number 1, and we want to do an ICMP echo. So we're going to ping. I can't track the status of the interface between R1 and R3, but I can ping it, and if it's down, then there won't be a return for that ping, and that is the way that we can verify whether it's up or not, that link. So ICMP echo. What is the destination IP address we want to ping? It's going to be 10.1.13.1. So let's just ping the inside interface of R1. That's it. We don't have to go all the way to R3. That's fine. Just the inside of interface of R1. If something happens on the other side of R1, that's it. We want DSW2 to start forwarding. And what is our source IP? Our source IP is going to be the IP address of DSW1's interface connected up to R1. Can't remember what that is. All right, so let's copy this right now. Remove that and type in do show IP interface brief. Our local IP address is going to be 10.1.10.2. So the interface of gigabit 1/0/10. Let's go back and we'll copy and paste that, and it's 10.1.10.2. How often do we want this to occur? Every 5 seconds. Frequency of 5. we need to turn it on. So to turn it on, we type in IP SLA schedule, and this is the schedule for instance 1. We want it to start now, and we want it to last forever. So the IPSLA instance has been set up. If we look at the output of do show IPSLA statistics, we'll see we have 2 pings so far that have been sent, and they were successfully returned. 3 now, because we're sending 1 every 5 seconds. So far that's working well. Now we need to create our tracking object. So let's give the tracking object a name. It's going to have a name of 100. And we want to track our IPSLA instance. And that IPSLA instance number was 1. And that's all I really want to do. I just want to track that IPSLA instance, meaning if the IPSLA is successfully returning a code of OK, meaning the pings are successful, then this tracking object is up. If, for some reason, the pings are failing, then the tracking object goes down. So if we look at the output of show track, we can verify here that for tracking object 100, it's the IPSLA instance of 1. It's currently up. The return code's OK. So we're happy. Tracking object is up. But now let's attach this tracking object to our HSRP group of 10. So standby 10. What do we want to do? We want to track. And what are we going to track now? Well, before we tracked interfaces. Now we want to track an object. So the object number is what goes here now instead of the interface itself. But we still want to decrement if the tracking object goes down, and we want to decrement the value. So that way there, the priority of the active forwarder gets decremented enough, so that way there, the standby device ends up with the higher priority. And then if preemption's on, which it should be, make sure you enable it manually. Preemption's on DSW2, it will take over the active forwarding role because it now has the higher, what? The higher what? The higher priority. So DSW1 has the priority right now of 200, and DSW2 has a priority of 150. Therefore, we need a value of 51 or higher to get DSW1's priority to 149 or lower. So let's specify a decrement value of 51. All right. So as of right now, everything should be fine. Everything should be perfect. If we look at the output of show standby for VLAN 10, we can see here that we still have our interface tracking object set up. So if the direct connection between DSW1 and R1 goes down, we can decrement our value. And if for some reason the ping fails to R1's IP address on the other side of R1 between R1 and R3, then we can decrement our value there as well. Look at the tracking object again, show track. It's still up. Show IP SLA. Statistics. We can see we've had 40 so far. So everything's good. Let's cause a failure now. Let's go to R1, show IP interface brief, and we're going to disable interface gigabit Ethernet 2/0. That's the interface that connects to R3. So configure terminal interface gigabit Ethernet 2/0. We'll shut it down, and we'll see what happens here on DSW1. The ping should start to fail. Therefore, our decrement gets lowered. Therefore, we lose what? We should lose our active status, and DSW2 should take over. And look at that. Because the IPSLA can no longer return a code of OK. So show IPSLA statistics, because the pings are failing, we can see we have a timeout now for our return code. Therefore, the tracking object, show track, is now in a state of down. So since the tracking object goes down, DSW1 has to decrement its priority. So standby for VLAN 10. Here we go. Tracking object 100 is down. decrement by 51, which it has. Therefore, DSW2 is what? The active forwarder in this particular case. So if we examine PC1 and we do a trace on PC1, we'll see that we're going through DSW2. Let's go back to DSW2. We'll go to DSW1, pardon me. And now let's reverse this. Let's say we fix the problem. So go to R1, type in no shut. What does this mean? Well, it means the pings are going to start being successful again for the IPSLA instance, which means the tracking object is going to go back up, which ultimately means that DSW1 will increase its priority back to 200, making it the active forwarder, as we see right here. So now PC1 should be using DSW1 again. So all of this is happening behind the scenes without PC1 or PC2 or PC3, anybody in VLAN 10 even knowing that this is going on, giving us the availability, the redundancy that we need to ensure that end stations have the connectivity that they need all the time.